Namaste and welcome back to the DSA classes. Today we are going to discuss another really interesting question called as the square root of a number, right? Now you may ask, oh my god, what is this easy question, finding a square root of a number? Great, let me now show the complete question to you. You are given an integer n, you have to compute and return the square root of n. Okay. If n is not a perfect square, you must return the floor of the square root of n. What does this mean? We will see. Do not use the square root function from standard library because all languages come with a built-in square root function, which obviously you must not use, right? Note, do not use sort function from standard library, which means to find the square root, no form of sorting should be done. Okay. Users are expected to solve this in big O of log n time, and this is the reason why it has been asked in Amazon, it has been asked in Microsoft, it has been asked in VMware, right? Now, why, you may ask? Let me show you. First of all, let us understand what you mean by the square root of a number. See, here basically in a number line, I am showing all the numbers to you, right? Now, if I ask you, right, what is the square root of 1? It is 1 only. What is the square root of 4? It is 2. What is the square root of 9? It is 3. What is the square root of 16? It is 4. What is the square root of 25? It is 5. Great. Because these numbers are perfect squares. All these numbers 1, 4, 9, 16, 25, they are perfect squares, right? 1 into 1, 2 into 2, 3 into 3, 4 into 4, 5 into 5 is what gives you these numbers. That's why they call as perfect squares, right? So, if I ask you square root of 4, 2, square root of 9, 3, square root of 25 is 5, square root of 14 is 3. Now, what if I ask you what is the square root of 23? Now, if you look at 23, you will observe one thing, that 23 is not a perfect square. You will not find a number which when multiplied itself will give you 23. Now, what will be the square root of 23 if you ask me? Common sense will tell me that the square root of 23 will lie between 4 to 5. It will be 4 point something. If it is 4 point something, he is saying that round it not to the higher value. Higher value means it will be seal. You must round it to the lower value, which means floor. So, floor will give me 4. So, the question says square root of 23 should be 4. That's what I am showing. Similarly, square root of 27, if I ask you, square root of 27 will lie between 5 to 6, but don't round it to 6. Round it to the lower value, to the floor, which means square root of 27 should be 5. And this is your question, and the complexity, the time complexity of the code that you are going to be writing must be big O of log n time complexity. I hope you are able to think. Now, how are we going to do this? Let me show you. Okay. First and foremost, let's look at a brute force approach, a naive approach. Assume n is 9. I need to find the square root of 9. Now, wouldn't you agree that square root of 9 will obviously lie between 1 to 9. It will lie between this range only, right? So, one way to do it is run a loop from I till n. That's what I am showing. Then just check if in case I take the I value, multiply it by itself, I into I. Will it give me n? If it gives me n, I is the square root of n, just return I. I hope you are able to think. And if in case I do that, all of you can see. Obviously, 1 into 1 is not going to be equal to 9, which means 1 is not the answer. Move I forward. Again check if 2 into 2 is equal to 9. No, 2 into 2 is 4, which means 2 is not the answer. Move I forward. I'll check if 3 into 3 is equal to n. Yes, 3 into 3 is equal to 9. 9 is equal to n, which means I, this 3 value is my square root. Return 9. Now, this is a brute force, right? Obviously, you will have to go till the end. So, what is the time complexity? Big O of n. Now, this is not how we have to do it. We have to optimize it, right? Now, how to optimize it and bring linear time complexity down to logarithmic time complexity? If you ask me, let me show you. Okay, so what I am trying to say is, let's change the n value to 25, guys. Let's change the n value to 25. I've changed n to 25. Now, I have to find square root of 25. So, obviously, square root of 25 will lie between 1 to 25. Now, first and foremost, the optimization I want to show you is that, will it really lie between 1 to 25? Should I go till 25? Now, let's look at it, okay. I'm showing a few numbers here for you, 1, 4, 9, 16, 25. And next to it, I am showing you the square root. What is the square root of 1? 1. What is the square root of 4? 2. What is the square root of 9? 3. What is the square root of 16? 4. What is the square root of 25? 5. If you notice, the square root will 100% lie somewhere in the half the value of the number, because 2 is nothing but 4 divided by 2. 9, you know, if you do 9 divided by 2, you will get around 4.5. Forget about it. 4 square root is lesser than the half the value. 16, if I divide it by 2, is 8. Again, 4 is lesser than that, so lesser than half the value. 25 divided by 2 is around some 12.5. 12 you keep. So 5 obviously is lesser than 12, which means if I have to find the square root of a number, should I go and check till the number itself? Not required. I can cut it by half, and from 1 till here, if I check in this range only, 100% the square root will be. So there is no need to go till n. You can check till n divided by 2. That is the first thing. Okay. So I am bringing the range till here and I am removing all these values. Now look at all of you guys. Between 1 to 12 only the square root will lie. Now if you look at this 1 to 12, don't you think it is sequential? Don't you think it is sorted? Don't you think it is, you know, one after the other? Now here you want to search for the square root. So searching on a sorted sequence, the moment you see that, you must understand that this is binary search question. I hope you're able to think, because the most optimal way in log n time complexity search can be done using binary search. And how to apply binary search? Simple. Set 1 as the low value, high as n divided by 2. So 25 divided by 2 is 12. Great. Now let's apply binary search. How will you use binary search? Very simple. I'm bringing the table low, high and mid. First time low is 1, high is 12, mid is 6. So that is 13 divided by 2. So mid is 6. Great. Now binary search, you know, as long as low is less than equal to high, we have to come do binary search. Now what will I do? Simple. Now mid is 6. I want to check whether 6 is the square root of 25. How will you check that? Check if in case mid value into mid value, is it equal to n? 6 into 6 is 36. Obviously it is not equal to 25. If it was equal, I would have returned the mid value, but it is not equal. Not equal means else. And now what? Now what means? I must now write conditions in such a way that if this is not the square root, I must see whether I must adjust the search range to the left side or I must adjust the search range to the right side. How will you check that? Simple. I will put if. If in case m into n is less than the n value. If it is less than the n value, if it was lesser than the n value, then obviously search should be to the right side because I have to increase the m value. So obviously low should become mid plus 1, right? And that is what I am showing. If it was not less and not equal, else means it is greater. Greater means I must reduce the value, so I should restrict it to the left, which means high becomes mid minus 1. That's it. That is your logic. Now see, what I will do is very simple. I checked if 6 into 6 is equal to 25. No. No means I will check if 6 into 6 is less than 25. No. It is actually greater than 25. 36 is greater than 25. If it is greater than 25, high should become mid minus 1. And that is what I am also showing you. High becomes mid minus 1. Low remains the same. Now between 1 and 5 I am searching. So 1 and 5 means mid is going to become 3. Any confusion? Mid is going to become 3. Now I will check if 3 is the square root. Simple. Again do. 3 into 3 is 9. Is 9 equal to 25? No. No means I would have, if it was, I would have returned 3, but it's not. Next I will come and check if 3 into 3 is lesser than n. Yes, 3 into 3 is 9. 9 is lesser than 25. If it is 9 is lesser than 25, then search must be to the right side. It will be the right side. I should increase the n value. So low is equal to mid plus 1. That's what I'm doing. Low is equal to mid plus 1. It becomes 4. High remains the same. 5 plus 4, 9. 9 divided by 2 is 4. Right? So now mid becomes 4. 4 into 4 is 16. 16 is not equal to 25. 4 into 4 is 16. Is 16 lesser than 25? Yes. Yes means mid value should increase. So low becomes mid plus 1. So see, low becomes mid plus 1. It becomes 5. Right? High is 5 only. 5 plus 5 is 10. 10 divided by 2 is 5. Mid becomes 5. If mid is 5, then 5 into 5 is equal to 25. Yes. Yes means n is your square root. 5 is your square root. Return that. You found your square root. As simple as that. However, this is not your complete logic, because one mistake that you have done is you have only and only thought about such numbers which are perfect squares. But we may get imperfect square numbers also. but we have not thought about it. What I am trying to say is, look at this. Now, I am changing the m value to 24, friends. Okay, so 1 to 24 I am showing. Now, you know you need not check the range till 24, right? So, you have to only check till half the number. So, n divided by 2. 24 divided by 2 is 12. I am removing the other numbers. Low is 1, high is 2. I am bringing up the table. So, 1, 12. 12 plus 1, 13. 13 divided by 2, 6. Mid is 6. 6 into 6 is 36, not equal to 24. Is 36 lesser than 24? No. Is 36 greater than 24? Yes. Yes means high becomes mid minus 1. So, see, high becomes mid minus 1, 5. Low is 1 only. 5 plus 1, 6. 6 divided by 2, 3. Mid is 3. Is 3 your square root? 3 into 3 is 9. 9 is not equal to 25. Next come, check if 9 is lesser than 25. Yes, if it is lesser than 25 means mid value should increase. So, low is equal to mid plus 1. So, low becomes mid plus 1. 3 plus 1 is 4. This is 5 only. 5 plus 4, 9. 9 divided by 2. So, now mid is 4. Right? Check. 4 into 4 is 16. Not equal to 24. 16. Is it lesser than 24? Yes. Yes means low should become mid plus 1. That is what I am doing. Low becomes mid plus 1. 4 plus 1, 5. High is 5 only. 5 plus 5, 10. 10 divided by 2 is nothing but 5. Now 5 into 5 is 25. Not equal to 24. Is 25 less than 24? No. Is it greater? Yes. Yes becomes high becomes mid minus 1. So see, high becomes mid minus 1. High becomes mid minus 1 means I have got 4. 5 minus 1 is 4. Low is 5 only. Low became greater than high. Condition of the binary search fails. You will come out. You will come out. But did you find the square root? No. But according to our question, if an imperfect square is given, which is 24, then 24 square root will lie between 4 and 5, correct? And you must round it off to the lower value, which means floor. Floor means 4 should have been the answer, right? And you did get 4. One of the mid values was 4. So, you have to always store these mid values somewhere. Because if you didn't find a perfect square, then one of these mid values only could have been your answer. How are you able to think? And rounding off is not seal, it is floor. Now tell me, obviously this condition will not satisfy, will never satisfy if it is a imperfect square. Now, either that mid value must be stored in this if block or in this else block. Now you logically think an answer. If a lesser value I want, floor value I want, should I store it at mid minus 1 or should I store it at low is equal to mid plus 1? Because very simple. Look at the condition. Whenever I multiply mid into mid and it is lesser than n, then that m value only could have been my answer. So, it is whenever it is lesser only I should assume it is my answer. If it is greater means here, lesser means here, seal means here, floor means here. Simple. How are you able to think? So, because the question is saying floor, what I will do is whenever it is lesser than n value, I will assume that is my result, and to do that, I will create a variable called as result and I will store the mid value inside this if block, because this is the lesser condition, this is the greater condition, floor and height. Any confusion till here? Now, if you do this, let us just retrace our program. First time, again I am resetting low to 1, high to 12. You found mid as 6. Obviously, 6 is not equal to, 6 into 6 is 36, is not equal to 24. Is it lesser? No. If it is not lesser, then I will not even store it inside the result, because I know it cannot be the result. It cannot be the result. I will go to high and I will tell mid minus 1. Okay, mid minus 1 means it becomes 5. Now 1 and 5. 5 plus 1 is 6, 3. Now 3 into 3 is 9. 9 is not equal to 24. Is 9 less than 24? Yes. Which means 3 could be a possible solution. So I will store it inside result. And low becomes mid plus 1. So 4 and 5. 4 plus 5 is 9. 9 divided by 2 is 4. Now mid becomes 4. Now 4 into 4 is 16. Is not equal to 24. Is it lesser than 24? Yes. Which means 4 could be a possible solution. So I will store it inside result. And low becomes mid plus 1. So 4 plus 1, 5. This is 5. 5 plus 5 is 10. 10 divided by 2 is 5. Now 5 into 5 is 25, not equal to 24. Is it lesser than 24? No. If it's not lesser, 5 can never be an answer. So I will not store it inside result. Come to else, increase the high value. So high becomes mid minus 1. So mid minus 1 means 5 minus 1, 4. Low is 5 only. Condition fails, I will come out. When condition fails and I come out, what is there inside result? What is there inside result is 4, and 4 is our expected answer. I hope you are able to think. So this is how you can round it off to floor. But if they change the question and told round it to seal, this result equal to n should come inside the else block. Any confusion till this point of time? Now that you understood the logic, and you also understood that if you are using binary search, and if you are first only reducing the size of the input from n to n by 2, that is your search range, and you are there further finding mid, reducing, obviously it is big O of log n time complexity only. I hope you are able to think. Anyways, now that you understood that you can solve it in log n, let us go and write some code. Alright my friends, let's write some code. I have defined a function called a square root which will take n and return the square root, which is an integer, right? Because we are rounding it off. Now very simple, n is 25 and I am passing it to square root and printing whatever it returns. Now first and foremost, before you apply any binary search etc., think about it. If in case the n value is 1, what is the square root of 1? 1 only. If in case n value was 0, what is the square root of 0? Square root of 0 is 0 only. How are you able to think? Because 1 into 1 is 1, 0 into 0 is 0. How are you able to think? Which means, why not directly check if n value is 1 or 0? If it is 1, return 1. If it is 0, return 0. Now how would you write that? Simple. Watch it. I'll just tell if in case n value is equal to 1 or n value is equal to 0. Now, if it is 1, then we must return 1 only. And if its n value is 1 only, so return n, I will tell. Okay. Or if it was not 1, it was 0, I will return 0 only. So if it is 1, 1, it's 0, 0. That's it. Next. I will come there and now I will do my logic. So int L equal to 1. And in fact, this L also, we can make it as 2 because we are already checking for 1. So if it is not 1 only, it will come here. So we will start from 2. Little bit more optimization. High is equal to nothing but n divided by 2. Good. Next I will come down and I will create an integer variable called as result, and I will initialize it to maybe initially 0. Okay, fine. Now what I will do is I will tell as long as low is less than equal to high. Then I will come here and what I will do is I will just find the mid. Mid is equal to low plus high divided by 2. After which all I have to do is check if in case that m is the answer. So m into m, is it equal to n? M into m, is it equal to n? If so, I will return n. Else, if in case, if m into m is lesser than n, then obviously low should become mid plus 1. Low should become mid plus 1, but that m could be an answer because it is not a perfect square and we have to find floor. So result equal to n. Else means greater. Greater means I will tell high is equal to mid minus 1. Now, if at all n value was a perfect square, this condition will be satisfied and you will return n. Now, if this condition is never satisfied and you come out of the while loop, it means your answer is inside result, just return that. That's pretty much your question. So, if in case I just scroll down, you can see 25, so we should get 5. So, if I execute, then we will get 5. I will make it as 24, in which case we should get 4. In which case we should get 4. So, it perfectly works, right? So, I hope you understood. Sometimes the most easiest of questions also can be asked in product based companies because it is not about solving the question. It is about efficiently solving the question. And efficiency comes into a programmer only and only if He has day in and day out practiced data structures and algorithms. He has developed his algorithmic thinking. So I sincerely hope all of you will be practicing as many questions as possible, because the more you practice, more your brain will get wired to think in terms of efficiency, think in terms of algorithms. I hope you're able to think. Anyways, I hope you enjoyed this program. I will see you in the next class. Till then, take care of yourself. Bye-bye.